Right, hi folks. We're back to the stats today, and I'd like to look at a couple of examples from the book and talk you through type 1 and type 2 errors. Now, errors come from significance testing, and if you imagine you've got a 95% significance, what you're saying is that you are 95% sure that the conclusion that you've made is the correct one. Obviously, there are times when it won't be the correct one. So if we concluded that we accept H0 and H0 is true, that is a correct conclusion. And if we rejected H0 and H0 was false, again, that is a correct conclusion. But say the probability of an event, of something coming up happening, is 0.02. That's still likely to happen, but on a 95% significance level, that would come out as telling us to reject, but it can still happen. So we get a type 1 error if the thing that happens is unlikely, but actually there's not been any cheating or no change. Now our other type of error is a type 2, and that comes from we accept H0, but H0 is still false, because again that can happen. So and that's called a type 2 error. Now the question in the book talks about a game of cards, and I'll read it out to you. It says, one rainy day during the summer holidays, a family of 4 were playing a simple game of cards. The game was one of chance, so the probability of any particular person winning should have been a quarter. After playing a number of games, Robert complained that his younger sister must have been cheating as she kept winning. Their parents quickly intervened and decided to carry out a proper investigation and carefully watch the next 20 games. So it's 20 games, and there's a probability of a quarter. So X tends to a binomial, 20 games and a quarter. Now if she's been cheating, you would expect the probability of her winning would be bigger than a quarter. So we're going to look at H0, which would be that she's not cheating. Probability would be a quarter, and H1, the probability that she is cheating, she's got a greater chance of winning, so we would expect probability to be greater than a quarter. Now what I'm going to look at is a critical region. And in terms of if it was a normal, obviously this is going to be blocked up with being binomial, but we're going to look for a value here where that I would expect to reject. This would have 95% likelihood here, and if we get in that critical region, 5% likely that it's going to happen, we think. So in order to look at my critical region, I'm looking for the probability that X is bigger than something or equal to it would be 0.05. So if I look down my tables, I've got 20 and a quarter. I can see when I get to 8, I've got 0.9591. So the probability that X is less than or equal to 8 is equal to 0.9591. So the probability that X is greater than or equal to 9 is 0.0409. So the critical region is X is greater than or equal to 9, and the probability of a type 1 error is 0.0409. So in the realms of normal probability, if she scored a game, if in 20 games she got 9 or more positive results, so she won the games, the probability of that happening is 0.0409, but that's normal. That can happen, and actually it's not that rare. So the probability of a type 1 error is 0.0409. So then we need to think about the probability of a type 2 error. Now that is that we reject we accept H0 given that H0's false. Well, if H0's false, probability is bigger than a quarter, we actually could do with knowing what that probability is, and actually in order to be able to proceed with this, we do actually need to know what that probability is. Now in this question we are told that the probability of her winning is actually 0.35. So we want to look at the probability that we accept H0. Now we accepted H0 here if x was less than or equal to 8. So looking at the probability that x is less than or equal to 8. Given that, we are now working with a binomial of 20 rolls and a probability of 0.35. And again, I'm going to look at tables for that. I've got 0.35 here, and the probability that it's less than or equal to 8 is 0.7624, which is quite interesting, quite a large statistic. So this is the probability of her cheating and actually getting away with it. 0.7624. Interesting. The probability that she doesn't cheat and gets accused of cheating is 0.409. The probability that she does cheat and gets away with it is 0.7624. So actually, it's quite a high probability that she could cheat and get away with it, I think. Okay, so this here is known as the actual significance level. And earlier on in my explanation I spoke about 95% significance. Actually it's 95% confidence. 5% is the significance for small level. So actual significance level is 0.409 because we're working in terms of whole numbers, aren't we? So when that's 9, then going above is 0.409. If we were working with continuous data, I think we could be a little bit more definite with this figure here, and we would know that it would be 5% for a type 1 error. Okay, right, hopefully that's given you a decent introduction, and I look forward to speaking to you next time. Thank you.